Hello, everyone. I'm so much happy and excited to meet you all on this beautiful day where we are going to discuss about the most important topic in terms of OOED, Object-Oriented Analysis and Designing, and the subject code is ITB4316. Now, the topic which we are going to discuss for today's session is the building blocks of OOE, which is nothing but the objects and classes here, the objects as well as the classes here. Now we are going to take a look into each and every topic that we see here in a much more detailed way. By the way, I'm so much happy and excited to meet each and every one of you through this video so that I shall have the satisfaction that I'm able to guide you based on this particular topic. So without any further delay, let's get started. Okay, here we go. As you can see here, we are going to dwell into the fundamental concepts of object-oriented programming, which is nothing but the objects and classes over here. We'll explore how classes serve as a blueprint for creating objects, how objects represent real-world entities, since I'm new with this particular effect tool, it's taking some time, but it's all right. Now, by understanding these core concepts about the attributes and the methodologies which define the characters and the behavior, students will gain a solid foundation for building robust and well-structured software applications. So the next one, what exactly is a class? That's what we're going to discuss here. A class doesn't represent a specific object. It defines the common properties and functionalities applicable to a category of objects. As you can see here, it is a template or a blueprint that defines the characteristics and behaviors of a group of similar objects here. For example, if you take a car, everyone knows what you might have a car for yourself or for your family, it all depends. A car class might define attributes like the color of a car, okay? It might be white or red or blue or whatever it is based on your liking, okay? And it might be the model, whether you want it as a hatchback or a SUV type or a sedan or a sleeper sedan. And then depends on the year of manufacturing and methods like starting the vehicle with your key and stopping the vehicle, as well as if you want to go fast, need to accelerate on the pedal, like ABCs of a car, acceleration, brake, as well as clutch. I'm speaking about a manual driving vehicle. So these attributes and methodologies would be applicable to all individual car objects created from the car class over here. Over here in terms of theory, think about this class like an architectural plan that details the specifications for building houses. The plan itself, the blueprint that you see over here, the blueprint, okay, isn't a house, but it guides the construction or an architect of many houses that share the same design. Using this design, the architect is going to go forward and draw the plan to go forward and build or construct a house. What exactly is an object? Let me tell you, an object is a single member of a class, just like there can be many different red apples. A car class can have numerous car objects, each with their own color. As you can see here, this is just a normal red apple that you see here. But this color can also be green or yellow, or certain times it can be deep red and so on, okay? In terms of a car example, there can be like many objects, each with their own color, model, year, values, and so on. Each object maintains its own state and can execute the methods defined in its class. An object is like an instance or a concrete realization of a class. It's a unique entity with its own set of attributes and methodologies based on the definition provided by its class. A specific red apple, which is here, it belongs to the class of fruit but has its own distinct characteristics like color, the size, the ripeness. For example, if you take a bite out of this huge, beautiful apple, it might be in the form of a solid, rocky taste, or it might be a small, mushy, like, what to say, not so rocky, but a soft nature. There is ripeness over here. We can also have small apples, small. We can also have huge or medium-sized apples. You can also have a huge apple here. Okay? I can perform actions like being eaten or peeled over here in terms of objects. Here we go. We're discussing about the key components of an object here. Think of attributes as an object's characteristics, like a person's name, okay, age or height, and so on. Methods are the action it can perform, like a human being can walk, I can talk, or walk and talk, right from the advertisement, okay, and perform like a task like running and singing as well. The specific attributes and the methods will be available depend on the object's class over here. We are speaking of a human being which has a unique name which is different from others, and if the name is also same, the initial is absolutely different, and so on. Hope you understand what I'm trying to get at. Now we have attributes and methodologies here. These are variables that store the data or properties of an object. They represent the object's current state, which means the properties of an object means whether the age, the name, the age, and other attributes related to an object. What is the object? Means it is you, a human being. That is the object. Methods are functions defined within a class that define the object's behavior. They act upon the object's data and can produce outputs or modify its state. So, here we discuss about the relationship between classes and objects. Between classes and objects. The relationship allows you to structure the code effectively. The inheritance helps you to avoid code duplication. Okay? While aggregation association enable you to model complex real-world relationship between objects. A class can inherit properties and behaviors from another class, creating a hierarchical relationship. The word hierarchical means we have the base class here. From that, something is derived over here. From this, something is derived over here. From here also, something is derived. From here. Like this, it can go on and on. Like a hierarchical structure, like a directory structure. This is called as hierarchical structure altogether. This is what inheritance is all about. Example, a child can go forward and get the features of its parents. You might have the eyes or the attributes or the characters of your parents. That is what it is. So here we are. Aggregation. In the previous slide, we discussed about inheritance. Okay. Now, inheritance, the main functionality behind inheritance is to avoid code duplication. Aggregation, on the other hand, enables you to model out complex real-world relationships between objects. An object can contain other objects as parts, representing A as a relationship. For example, a car object, which is this one, car object, might have a wheel object as a part of its composition, as a wheel. Now we can go forward and see other important car objects with real objects like headlight, okay, and also the fog light, the mirrors. This entire car has a relationship with all these entities over here as one entity. Okay, wheels, headlights, rear view mirrors, and fog lamps, and so on. This is aggregation. Next, we have association here. Now, apart from inheritance, I told you, apart from code duplication, this association as well as the previous slide aggregation, it helps the user to model out or to create a complex real-world relationship between objects. This is one object here. This OBJ, 2 here, and 3, and so on. Okay. Now let's take a look at what this association is all about. The objects can relate to each other without necessarily being part of each other's structure. This represents a uses-A relationship. For instance, a car object might use a GPS object for navigation. Obviously, yes. If you take a car, on the dashboard, you see a small screen. Okay? And that screen has a Google map or Apple CarPlay or you can mirror your entire phone in that particular, the mirror your particular phone in the dashboard screen structure of your valuable car. Now it depends on the car make and model over here. If a normal car means you can keep your phone itself as a Google map, or else if it's you point a most expensive car, it comes along with an inbuilt default screen to share anything and everything from like a format of mirroring your entire phone screen onto that particular screen. You can use your phone on that particular screen altogether, to be precise. I might be wondering, what is this classroom doing here? Understanding objects and classes forms the foundation of object-oriented programming. By grasping these concepts, students you can create well-organized, modular, and a maintainable software. Classes act as blueprints of a building. Objects are unique instances, and attributes and methodologies define the characteristics and behavior. Now coming to this example here of a classroom. Okay. This classroom where you're all sitting and learning your day-to-day subjects. Okay. Now, in order to help you understand this concept, this is a classroom and you are all called as students and you have unique attributes like name of the student. There are 63 students in this classroom, including you who's listening to this particular audio and seeing this video. You have a name, a specific age, and what sort of a semester you're in right now, and which year of engineering are you pursuing right now. Every individual student in this class is treated as an object of this class, which has its own values for these attributes. The student, the name STUDENT class, might also have methodologies or methods like study. Basically, a student is expected to study. Let me write it here. Study. And write the examination. Exams. There you go. Okay. And calculate and finally, when you finish your certain semesters, okay, from first, second, third, fourth, and so on, there is something just called as CGPA, which all students should perform, calculate right from day one after the first semesters. This demonstrates how classes and objects help model real-world entities and their interactions. This is what I want to discuss with you for today's video session. I really want to thank you for joining in today's session where we had discussed about the fundamental concepts of object-oriented programming, which is objects and classes. So I hope that this particular video session would have helped you in a much better way. If there's any sort of doubts that might be lingering in your mind, feel free to talk to me regarding this. I will be more than glad to help you understand this concept in a much better way. So thank you so much for joining me today's session. And I want to thank you all. Let me just rub it off real quick. Thank you all for joining me today's session and all my good students. Love you all. Loads of love. Take care and God bless. Bye-bye.